All right, let's just jump right in. Forget everything you think you know about how fast science moves. We're living in 2026, and something absolutely fundamental is shifting under our feet, right now. The very idea of what a scientist is, well, it's changing completely.
So that leads us to the huge question we're tackling here. Can an artificial intelligence do more than just, help us out? Can it actually go out and discover a whole new branch of science, a field we don't even have a name for yet?
And look, this isn't some sci-fi fantasy we're talking about. This is real. Over the last year, a totally new kind of researcher has shown up on the scene. One that doesn't need to eat or sleep or take a coffee break. The AI scientist is here.
What we're really seeing is the rise of something called Agentic Science, and this is a massive, massive leap. AI is not just a fancy calculator anymore. We're talking about models like Gemini 3 and GPT-5 that can come up with a hypothesis, design the experiment, analyze the results, and, get this, even write the first draft of the paper, all by themselves.
But to really get your head around how big a deal this is, you gotta look at the journey that got us here and how incredibly fast it's been. It's the story of how AI went from being a simple tool to a genuine teammate in the lab.
You can basically break down AI's role in science into 3 stages. Way back when, it was in the library phase, acting like a super smart librarian. Then, just a few years ago, we hit the specialist phase. And now, since 2025, we are firmly, and I mean firmly, in the agentic phase.
And you can see this change in the real world. The library phase was just about searching through mountains of data. The specialist phase gave us game changers like AlphaFold, which solved the massive problem of protein folding. But the agentic phase, wow, that's where AI becomes the project manager, the conductor of the entire scientific orchestra.
So this new agentic power isn't just some theory. It's being put to work right now in these absolutely revolutionary places called self-driving labs.
And the difference is just night and day. Human research is slow. It's one step at a time, and it's limited by the fact that we're, human. But these AI-driven labs, they operate 24/7, they run an experiment, learn from it instantly, and then immediately kick off the next one in this perfect, non-stop loop of discovery.
So, what's the result? An acceleration that is just mind-blowing. In fields like materials science, we're seeing a 100-fold increase in the speed of discovery. Let me say that again, 100 times faster. What used to take a whole decade can now be done in just a couple of months. It's wild. This means we're not just looking at a slight improvement. This is a whole new ballgame. We are literally watching the birth of a new field, something you could call autonomous materials science, where the AI is truly in the driver's seat.
Okay, so making existing science faster is one thing. That's incredible. But creating a new branch of science, that's a different level entirely. And for that, we need to look at AI's most unique and maybe its most powerful ability.
This quote just nails it. Think about it. We humans get stuck in our own lanes. A biologist, a physicist, a chemist, they all speak their own specialized languages. But in AI, it's fluent in all of them. It sees this giant single tapestry of knowledge, and it can spot the connections between fields that are totally invisible to us.
And here's a perfect example from just last year. An AI was given this wicked hard problem in discrete math that had researchers totally stumped. So what did it do? It just reached over into a completely different field, continuous mathematics, grabbed an idea, and used it to solve the problem. Boom! It just tore down a wall that humans had built between 2 fields.
And that ability, to pull ideas from anywhere and everywhere, could be the seed of a brand new branch of science. Some are starting to call it computational universalism. It's basically the study of the hidden patterns that connect everything: biology, physics, math, all of it. A study that's only possible when you have an AI that can see the whole picture.
Of course, this incredible power comes with some equally incredible challenges. This is not a simple good news story. This is definitely a double-edged sword.
For every amazing opportunity, there's a serious challenge. The speed is fantastic, but it makes human oversight almost impossible. And its objectivity is a huge plus, but that leads to the biggest problem of all, the black box issue. The AI gives us a revolutionary answer, but when we ask it how it got there, they can't tell us. And that leads us to the most important question of this entire new era. If an AI discovers a new law of physics, but we can't follow its logic, can we actually trust it? I mean, really?
See, the black box isn't just some philosophical debate. It creates a very real, very practical problem.
a crisis of reproducibility. The absolute bedrock of science is that other people have to be able to repeat your results. If we have no idea how the AI did what it did, verification is impossible.
So where does that leave us? Is this whole new world of science doomed before it even starts? Not necessarily. It just means the role of the human scientist is about to change more than it has in all of history.
Let's just be totally clear about this. The age of the lone genius, the single person having a flash of insight that changes the world, is over. It's done. The problems we're tackling now are just too complex for that.
Instead, we are entering the era of collaborative intelligence. This is not about AI replacing humans. It's about AI becoming a true partner, a co-scientist that amplifies our own intelligence.
And the results of this partnership are right around the corner. We fully expect to see the first FDA-approved drug that was discovered from start to finish by an AI next year. And beyond that, we're talking about AI-powered quantum computers that can simulate the universe at the subatomic level, creating little digital worlds for us to explore.
And that's really the key takeaway here. The future of science isn't human versus machine. It's a team sport. Think of it this way. AI is going to be the explorer, hacking through the dense jungle of data to find whole new branches on the tree of knowledge. Our job is to be the climbers, to make sense of those new branches, to interpret them, and to figure out what they mean for all of us.
Which leaves us with one final fascinating question that kind of sums this whole thing up. If an AI is a true partner in discovery, a co-scientist, should we start putting its name on the research paper? What do you think? That's a question we're all going to have to answer, and probably a lot sooner than we think.